Welcome to Wagner High Quality Lubricants. Today we will see how Wagner microceramic nano glide compounds are effective in reducing the power consumption. We are using a Brugger test rig, which is actually a real-time test rig. It consists of a motor of 0.34 HP, an ammeter and applied load indicator. The turbo pair consists of bearing steel which is hardened to 58 to 60 Rc, rotating at 750 revolutions per minute, and cylindrical pin of N31 of hardness 30 Rc. During the simulation, variable loads up to 110 Newton were applied. First, you add 50 milliliters of commercially available mineral gear oil into the oil sump. After cleaning the oil slump with a plain cloth, we now switch on the device. We notice that as the load is applied gradually, the ammeter shows a reading of 1.3 amperes. Here, with the load applied at 80 Newton, the ammeter shows a reading of 1.5 amperes and begins to increase slowly. Here the load applied is 90 Newton. The reading shows 2.1 amperes. Here at load 100 Newton, it shows 2.3 amperes. At applied load 110 Newton, it is 2.35 amperes. Now we vary it to 70 Newton. We see it is 1.9 amperes. At 110 Newton, it shows 2.5 ampere. We see that at load 110 Newton, it shows 2.5 amperes. On further operation, a high fluctuation of ammeter reading is seen, which is captured in slow motion for better understanding. Here the load applied is 110 Newton. Here it crosses 5 amperes, which results in stoppage of the Brugger test rig. Now we will be adding 5% microceramic nano glide compounds to the 320 CST gear oil. We see that microceramic nano glide compounds easily mixes with the gear oil. By using a simple glass rod, a homogeneous mixture is obtained. This mixture is then poured to the oil sump and the test is conducted by gradually applying the load. As the load is applied gradually, we can observe the reading at the ammeter. At load 85 Newton, we observe it's 2.1 amperes. At load 90 Newton, we observe it is at 2.3 amperes. Here, by reducing the load to 78 Newton, we observe the reading at the ammeter. It shows 2.1 amperes. Now we increase the load to 90 Newton and check the ammeter. It shows 2.1 amperes. On increasing the load to 100 newtons, we see that it shows 2.1 amperes. Further on increasing the load to 110 Newton, we check again with the ammeter readings. We see that it is between 2.1 to 2.2 amperes. Hence we see that under variable loads there is significant reduction in current consumption, which is possible through Wagner ceramic nanoglide compounds. The images on the left represents roughness of the surfaces, which was measured using three-dimensional profilometer. They have shown higher roughness parameter in 320 cst gear oil, whereas the images to your right shows the roughness of the 320 cst gear oil, which is considerably reduced. This was possible due to the addition of Wagner microceramic nanoglide compounds. Thus summarizing, we have seen that in the absence of Wagner microceramic nanoglide compounds in 320 cst gear oil, there was high fluctuation of ammeter readings and the Brugger rig stopped when the load was 100 to 110 Newton. The ammeter reading suddenly rose over 4 amperes, even touching 7 amperes before the rig stopped. On the other hand, with the addition of 5% volume of Wagner microceramic nanoglide compounds, There was no power fluctuation even under variable loads. The ammeter showed a steady reading of about 2.1 to 2.2 amperes even at 110 Newton. Thus, with the addition of Wagner microceramic nanoglide compounds to your compressor oil, gear oil, spindle oil, it will not only reduce friction between the mating pairs but will also reduce the power consumption in the equipment. Hence we can say that, industrial applications have shown a significant fall of 10% to 25% reduction in power consumptions along with reduced frictional wear, which enhanced the performance of the equipment, and increased the oil change interval, creating a significant payback for the customer.